Welcome back to section 14.4, page 2. Okay, we're going to read this problem. It says, assume that the distribution, let's go ahead and add, is normal and has a mean of 25 and a standard deviation of 5. We're supposed to use our 68, 95, 99.7 rule to find the percent of values in the distribution that we describe. So they want to know between 15 and 35. Okay, so the way we're going to do these problems is the first thing we're going to do is we're going to put the mean right in the middle, which is 25 for this particular problem. Then what we're going to do is we're going to break up this line down here and put some numbers on it. We know that basically within, let's go ahead and write this. This is within 1 standard deviation. This is within 2 standard deviations, and this is within 3 standard deviations, okay? So basically all of our data is included in 3 standard deviations. That means go 3 this way, go 3 that way. So the first thing you're going to do for all these problems is try to equally distribute from the middle to the end of the curve in 3 equal pieces, okay? Doesn't have to be perfect, just approximately, okay? So you do that. Then you're going to go ahead and figure out what those values are based on the standard deviation. This is moving up 1 standard deviation. So if a standard deviation is 5, we would say 25 plus 5, we are now at 30. Then we're going to move another standard deviation up. So now we're at add 5 to that, 35. And another standard deviation up leaves us at 40. Now we're going to go backwards. So moving 1 standard deviation, meaning we're going to subtract. So we get to 20. Removing another standard deviation, 15. And one more, 10. So you're just adding and subtracting 5. Now if the standard deviation were something like 2, you'd be adding 2 to get 27, and then 29, and then 31. If the standard deviation were 10, you get 25, 35, 45, and so forth. You get the idea. Okay, so for this particular problem, sorry, there's an airplane going by. For this particular problem, we want to be between 15 and 35. So we're going to make marks and shade that. So 15 to 35, that's where we want to be. Let's go ahead and shade that area. And I'm getting smart here, getting out my colored markers here. Okay, so that's what we have here. Okay, how do we know what percent of the data is there? Well, we count in terms of standard deviations. How far do we move from the mean? 1 standard deviation, 2 standard deviations. So this is 2, we're going to say plus 2 standard deviations. How many do we move this way? 1, 2. So minus 2 standard deviations. So all together, this is within 2 standard deviations of the mean. Okay, there's the mean. So what percent? Well, 95 is 2 standard deviations. So this represents 95% of the data. So we can go ahead and answer our question. We would say 95% of the data is between what 2 numbers? 15 and 35. And that's what we were supposed to find. Okay? All right, on to the next problem now. Now we're supposed to answer above 15. So we're going to do the same thing. We put the mean right smack dab in the middle, and then we divide this up into 3 equal pieces. So 1, 2, 3, and then go this way, 1, 2, 3, and then count in terms of standard deviations. 25 plus 5 is 30, then 35, then 40. Down, subtract, we get to 20, 15, and 10. Now we're going to shade what this particular problem wants, above 15. So we draw a line at 15 and shade above. So everything all the way to the end of the curve. Okay, so here, here, here. Okay. All the way to the end. Okay, So this, if we look at this, here we're within 2 standard deviations, 1, 2, but here we're within 3. So how do we figure that out? Well, let's draw a little dashed right here. We know what this is. This part right here is 95%. So obviously when we add on this little, what we call a tail, so let's go ahead and mark that, all of this down here, okay? That there, what is that? How much is in that orange piece? Well, let's think about it. If we know that the yellow represents 95%, the area under the entire curve is 100%, what has to be left over for these tails? Well, 100% minus the yellow, which is 95, would leave us with 5. So let's write down all of that. Okay, so the entire, the area under the entire curve is 100%. Okay? Then the yellow represents 95%. So what's left for the end pieces? And we call them tails. Okay, what's left? Well, 100% minus 95% equals 5%. But that's for both tails. If we want what's just left in this one, how would we find that? Remember, this whole curve, we could fold it right here to be symmetric. So what's in here has to be the same as what's in here. So we can divide that 5% by 2. Okay, so the orange tail equals 5% divided by 2, or 2.5%. So this is 2.5%, this is 2.5%. So that when we add all of these up, we get a total of 100%. Okay? So to answer the question then, we're going to say, we're going to add the yellow and the orange because that would be what's above 15. So we would say 95% plus 2.5% is equal to 97.5%. We do not want this. We don't have it shaded. So we would say 97.5% of the data is between, or not between, is above 15. Okay, and that answers that one, and I've got to close the window. Read the next problem. Sorry, I've got a neighbor making noise. Okay, so the next problem says, the SAT critical reading scores for college-bound seniors in the year 2015 has approximately normal distribution with mean 495, standard deviation of 116. There were 1,698,521 test takers. Boy, that's a lot. Okay, first question. Does the data look like it has an approximately normal distribution? Now, they told us it was, but I want you to look at it and decide. Does that look like a normal distribution? Well, hopefully it does to you. It's not perfect, but if you go like this to it, you know, it's approximately bell-shaped, okay? So you should feel pretty good about it being approximately normal distributed. So let's say yes. Okay, now what they want us to do next is show the scores that correspond to 68%, 95%, 99% using this rule. So we know what we're supposed to do. We have to go ahead and put the mean in. So what's the mean in this case? 495 goes right in the middle. Okay, then we're going to do exactly what we did before, divide it into 3 equal pieces. So 1, 2, 3, 1, 2, 3. How are we going to be moving? Well, we're moving in terms of standard deviations. So we're going to add 116. So you might want to get out your calculator and make this a little easier for you. So you're taking 495, and then you're adding to that 116. Okay, so what do we get? We get 611. Then add another 116. That gives you 727. And then another 116, and that gives you 843. Okay, now we want to go down in the other direction. So you're going to take 495 and you're going to subtract 116. Why 116? That's the standard deviation. We get 379. Oops, 379. Okay, and then subtract another 116. What do we get? 263. And then subtract another 116 and we get 147. Okay, then we can go ahead and show within one standard deviation, that's 68%. So we're just going to go down one standard deviation, so down to the first marking here, and then up to the first one here. And within here now is 68%. Okay, because that's what it means to be within one standard deviation. So this is within one standard deviation. Okay, second one. Well, we don't have to go through marking it all over. We know these numbers, so let's go ahead and put them on here. Okay, so we go 611, 727, and 843. And then we go down. We're at 147, 263, and 379. This time 95%. Well, that's within 2. So go down 1, 2, draw a line. Go up 2, 1, 2, draw a line. And we can say that we know that 95% of the data would be within these values, 95%. So between 263 and 727. And that's within 2 standard deviations. Okay, last one here, 495, right in the middle. Then we go 1, 2, 3, 1, 2, 3, and put these values on again, 611, 727, 843, and then down 379, 263, 147. This time we're going to the ends there, so it's hard to kind of even draw it. We just want to make sure we're shading the entire thing here. Okay, make sure we show the whole thing. And that represents 99.7%. Okay, so let's go ahead and circle the scores we're talking about. Here we're talking about 379 to 611. Here we're talking about 263 to 727. Here we're talking about 147 to 843. Okay, so that answers that question. Now we have our very last one here that we're going to answer. Actually, let's, well, we'll try to fit this in. Okay, so using this rule, find the percent that are below 727. So when we do this, we already have our markings, 495, and then we're going to go up 611 and 611, 727, and 843. We want below 727, so we're going to go here, and we're going to shade all of this, okay? Now, if we recall from that other problem we did here, let's do 147, 263, and 379. Okay, so when we do this, it's that same sort of situation where we know what's in here. Okay, what's in 2 standard deviations is our 95%, right? That's our 95%. So we have 95% in here, in the yellow. But what about this little tail here? We want this too, because it says anything that's below 727. So what's this part going to be here? Well, remember what's left for the tails. If the whole thing's 100, we subtract 95, we get 5% here. But that's for both of those, so we have to divide it by 2 to get 2.5% here. So remember what we're doing. We're saying 100% minus 95% equals 5% for the tails. Okay, but there's 2 tails. So divide by 2. okay, for each one. Okay, so to answer the question, we're going to say there is 95% plus 2.5%, which is 97.5% of the data is below 727. Okay, and that answers the question there. Go ahead and do your classwork and then come on back.